So for those of you who have already attempted this question, you might scroll down to solution at the bottom and realise that this is actually the incorrect solution I've included in your booklet. So unfortunately I must have got that from the wrong question when I pasted it in. So the answer for this should actually be 2 ln2 minus a half units squared. Notice how it's asking for the area. And we're just going to work through how we actually come up with this solution. Now again, standard these questions, either you'll be given a diagram or you'll be requested to sketch a diagram. So that's what we're going to do. We're going to draw out some coordinate axes. Like so. And then what we need to do is we need to graph these. Now what's going to be quite important is, first of all, is we need to find out where they actually meet. So let's solve these simultaneously. So 1 on x equals 2 minus x. We're going to times across through by x, so we're going to, with 1 equals 2x minus x squared. Now we formed a quadratic, so we're going to rearrange this quadratic. I'm going to make x squared positive, so I'm going to bring that over to the left hand side. I need to bring over the 2x, so we get negative 2x plus 1 equals 0. It's a quadratic, so we want to make this equal to 0. And then to solve this, we need to factorise it, and we actually end up with a perfect square, which is x minus 1 squared equals 0. Therefore, x equals 1. Now, we can say that when x equals 1, y is equal to, we can use either function to work this out. If we sub 1 into 1 on x, we get 1 on 1, which is just 1. So therefore, these curves meet at the point 1, 1. Now, the fact that they've only got one point of intersection is quite interesting, because what that is telling us is the line y equals 2 minus x is actually the tangent to y equals 1 on x. So if we go through and sketch these, we'll start off with the graph 1 on x. Notice I'm only drawing it in the positive quadrant. You can draw it in down the negative quadrant as well, but we'll come back and discuss why that's not really going to be relevant to us later, but it's not going to be relevant at all. Now we know that they intersect at the point 1, 1, so we can mark this on here. We can see that y equals 2 minus x has a negative gradient, so therefore it's going to look something like that. And we can find these points of intersection with the axis. That would be 2, and that would be 2 as well. And now we're asked to find the area between these two curves, the x-axis and the line x equals 4. So let's just mark on x equals 4. You'll notice my scale is going to go here, because x equals 4 is actually somewhere over here. But just to illustrate the point, we'll put it in there. So there's the line x equals 4. And then the boundary that's shared around here, so the boundary, to find the area between these two curves, the x-axis and the line x equals 4, well, that area is actually this region here. And you'll notice we're going to have to split this up into two different areas, because this region, if we put a line down here, this region here is actually an area that's between the two curves, between the two functions, and this area here is just below the function 1 on x. So when we're working this out here, the area is equal to a1 plus a2. Now, the area for a1 is the integral. Now, between where the curves meet, so the curves meet up here at 1, 1, so between 1 and when x is 2, of the top curve minus the bottom curve. So the top curve is 1 on x, minus the bottom curve, which is 2 minus x. I'm just putting a bracket around that. Because of the negative in there, it can be quite confusing. If you don't put the bracket around, it's an easy mistake to be made there when simplifying this dx. So that's the area of a1. Plus the area of a2. Well, the area of a2 is the integral between 2 and 4, and it's just the area between 1 on x and the x-axis, so therefore we only need to integrate 1 on x here with respect to x. Now, we can then work all this through. I'm just going to simplify this expression here before we do, just to eliminate the negatives that may cause us some problems. And then we're going to go ahead and integrate this. So we integrate this, we get 1 on x integrates to ln x minus 2x, and x integrates to x squared on 2, between 2 and 1, plus, if we integrate this, we end up with ln x between 4 and 2. Now, next stage is we need to substitute in our values. So we end up with ln2 minus 2 times 2 is 4, so minus 4. 2 squared is 4 on 2 is 2. Minus ln1, minus 2 lots of 1 is 2. 1 squared is 1 and 2, so a half. And then we substitute in for this expression here. So we end up here with ln4 minus ln2. All right, lots of things we can simplify here. So let's look at this first bracket. We end up with ln2 minus 4 plus 2, sorry, is minus 2. Minus ln1, well, ln1 is just 0. And we've got minus lots of minus 2, so plus 2. Minus lots of a half, so minus a half. And then in this end bracket, ln of 4 minus ln2 is the same as ln2. And that, again, is just using the log law that if you've got ln of a minus ln of b, that's equal to ln of a over b. And then what we can do now is we can simplify this. The negative 2 and the 2 cancel each other out. We've got an ln2 here and an ln2 there, so that's 2 ln2 minus a half. We can actually also write this as ln4 minus a half, because we can take this 2 up to be the power there based on log laws, and then square that. And again, that's area, so that will be units squared. All right, so again, another good problem in terms of finding the point of it. It's always important. The sketch is very important, and the graph is very important. And even if you're given a graph, it's still worthwhile finding points of intersection, clearly labelling and shading in the region that we're being asked to find the area of as well. And then just double checking, do we need to break this question down into 2 different regions?